Okay, and so here demand and supply is an excellent example where we can use mathematical function to model a business problem. And so now, anytime in a business or anytime doing a business modeling problem, there are always two important quantities, two important variables to consider. So here I'm going to say we're going to let Q to represent the quantity of a commodity being produced and sold. And we're going to let P, a different variable, to represent the price of each unit of that commodity, of course. Both demand and supply are rules that relate quantity and price. And so in that way, demand can be regarded as an equation. P equals some function of Q. And so now all the detailed explanations of how demand and supply work and how the rules came out from are all being explained in a formal econ course. Here we're only going to look into the strict mathematical perspective of that. But so usually demand as a curve here is a curve that when we're putting that on as a curve, when we're putting demand as a curve on the graph here, then we're putting the price on the vertical axis and the quantity on the horizontal axis. And usually the curve is a curve that's going down. And as I said, the reason why the curve usually going down, the demand curve usually going down, reason for that can be explained in detail in a formal econ course. Supply is a different rule that relates price as a different function. Let's say G of Q. So like as I said earlier, demand and supply are all rules that relating price, and these are my lowercase variables, by the way. So relating price and quantity of the commodity. And so usually, and as a tradition, price is being put on the vertical axis and Q is being put on the horizontal axis. And so when we're putting supply as a function, as an equation on the graph here, it's gonna usually come up with a line that's going up. Why the line is going up? The details of all of that explanations in details are once again being explained in any formal econ course. And so developing the idea a little bit further to have a nice full mathematical understanding of that, then demand, when we're looking at demand here, then Q can be regarded as the quantity that consumers in the market demand. And then on the other hand, pricing on each unit is P here is the price per unit that consumer are willing to pay. So that's why it makes sense that when we put the demand curve on the graph where the P variable goes on the vertical axis and the quantity Q goes on the horizontal axis, then generally the demand curve is a curve that's decreasing or going down. So here's the demand curve. And so it's going down, so you can see that it's going down because as more quantity being demanded, or as the quantity being demanded by consumers become larger and larger quantity, then consumers can only pay or are willing to pay a lower amount of price per unit, per item. Now, for supply, on the other hand, the same two variables, but Q represents the quantity, that producers can produce or are willing to produce. Variable P represents the price, per unit, per item, that producer or willing to produce. Q units. And so when we graph the supply graph, then, and this time we're going to purposely put the supply graph together with the demand graph that we have seen earlier. And so once again, when we actually graph the supply graph, then the curve makes sense to increase from the left to the right. And so here is our supply curve, and it's increasing in a sense that for the producer side, then as quantities getting larger, then producers ask for a higher price per units, of course. And so now when you put the two graphs together, the supply graph and the demand graph right here together, then there will be a point where the two graphs cross each other. And so that point is indicating that there has to be a quantity, and correspondingly there is a price where supply and demand can be satisfied on both sides right here. So there is a quantity where the consumers demand and suppliers can supply. And then there is a price correspondingly at that quantity. Correspondingly, price is going to be also the price where suppliers and demanding consumers are happy together. And so in economic, that point here is where we call that the equilibrium point. So this is equilibrium, or sometimes we might use the term market equilibrium. And so of course this quantity Q here is the specific quantity where we call that it's the equilibrium quantity, and this price here is called the equilibrium price. And so now, after taking that understanding about demand and supply, let's look into one of our example here and find out how we can, what kind of problem we can work with demand and supply here. But so in my example here, let's say we give the demand, given that the demand and supply functions below. So the demand here, in this problem, the demand is being specified as a rule P for price equals 67,374 minus 4.77 cube. And then supply itself, P equals 3.78 cube. And so clearly speaking, demand and supply here, there are both functions. P is price as function of the variable Q here. So quantity, a lot of time in the market, quantity is what determines the price here from both sides, from both parties. And so back into my screen of the Microsoft PowerPoint here, then so now coming to our first question regarding this demand and supply problem is that we would like to find a price when the quantity demanded is being 287 units. And so switching over to my working board here, then demand is this function, P equals 67,374. So with demand being this function right here. And so clearly when it's asking find the price when the quantity demanded being 287, that means Q is given to be 287 units. So Q is being 287 units. So that means finding the price, the demanded price in this case is going to be simply just substituting in the Q value into the variable Q of our equation. And so what we have here is 67,374 minus 4.877 times 287 units, substituting in. Alright, so calculation shows that the price in this case at quantity demanded to be 287 units, and price came out being, it should be $66,005.01 for each unit. And so now in the same example here, same problem here, let's look at a different question. So now we want to find the quantity supplied when the price is $537. So if we're now looking into the supply curve right here, then supply follow this rule that pricing equals 3.78 times quantity. And so here we know that when price is $537 per unit, we want to find out what quantity the suppliers or the supplier will be happy to produce. And so that is nothing but just we're substituting, and by the way, let me write it down right here, but P equals, when P equals $537, then we're going to substitute that value for P into our supply equation. And so here we're looking at, we produce for ourselves an equation 537 to equals 3.78 Q. And so now at this point we have an equation to solve, and remember our goal here is we're looking for the quantity, at what quantity, find the quantity supply when the price is 537. So here we actually solve this equation for Q. And so solving this equation in our class right here, in the learning of our class, I'm now going to point out a couple of options right here. And anytime we're solving an equation, so well, the traditional method is just to solve that by hand. My equation, let me start out by rearranging the equation here, 3.78 Q on the left hand side. A lot of time we are more comfortable with putting the variable terms, all the variable terms on the left hand side, and then all the non-variable terms to the right hand side. And so here I'm just simply going to divide both sides by 3.78. And then we come up with, in the next step, Q has to come out with value being 142.06. So now that the calculation has shown the 142.06, but keep in mind and remind yourself that the Q variable here represents quantity, the number of units that we're producing for suppliers right here. We're producing and selling. So we can't have a decimal in your answer over here. And so we're just going to round to the nearest whole number that near it. So Q here is going to round to 142 here, this problem. So a lot of time when we're doing these supply and demand problem right here, then quantity comes out. If it's a decimal, we round to the nearest whole value. And so now continuing with this same example over here, but getting into the next question. Now we're getting into the actual core of this understanding right here. But now this question here, say find the equilibrium quantity. And so now we mentioned that equilibrium point again on that I explained a little moment ago from the graph. And so here let me bring up a graph again. I'm not saying that this is the exact graph of your demand and supply, but demand is a graph that's heading down like this, where we put price on the vertical axis and Q on the horizontal axis. And so let's say this is your demand curve, and it's being in our function here. And I'm not saying this is exactly the curve for that, but let's say our demand function here is in the form of, in the expression P equals 67,374 minus $4.77 Q. Now supply on the other hand usually goes as, and in this case it has no coefficient and no constant term, so it starts dry from the origin heading straight up there. And this is your supply curve. And the equation for this is P equals 3.78 Q. And so equilibrium quantity. So now remind yourself that on a graph like this, we put quantity on the horizontal axis. So the equilibrium point, as I mentioned earlier, is right here, where the supply and the demand curves are crossing each other. And so the quantity we're looking for in this question here is particularly this quantity. But we need to spend some time doing the math work to find out at which quantity, like right here, at which quantity we're going to reach demand and supplies being the same. And so in that way, so mathematically speaking, two curves is going to cross when their equation can be set equal to each other. And so the supply is 3.78 Q, and the demand is 67,000 as a function of Q. I treat both of these as function of Q right here. So 67,374 minus 4.77 Q. These two expressions here, they're both priced, but pricing in supply and pricing in demand need to be equal. and that's always the starting point to find out the variable where the two curves cross. Yeah. And so now we are going to solve this equation for Q again. It makes sense that, back to the question, it's asking for the equilibrium quantity. So the variable that we're looking for the value here is the variable Q over here. So it's perfectly consistent with the fact that all we need to do here is to solve this equation for Q. And so now, solving this equation, once again, we can do that. We can solve that equation by hand. That I'm going to add. So 3.78 Q equals 67374 minus 4.77 Q. I'm going to add this term to the other side. And so adding 4.77 Q from both sides. And that produced for me in the next equation right here 8.55 Q on the left hand side to equals 67,374. And so now the next step here is simply to divide both sides of this equation here by 8.55, positive 8.55. And so calculation now shows that quantity comes out being exactly 7,880. And so strictly as solving an equation, we solve the Q value that satisfies this equation. The left hand side equals the right hand side. But in the practical meaning of this particular problem right here, then Q right here, we call that it's the equilibrium quantity. All right, and so now the last question of the example here, it's asking for find the equilibrium price. And so back to the demonstration curves again. I'm not saying that my curves are up or on scale or being or the exact curve of the demand and supply problem we have here, but it does demonstrate the idea. But now what we've found in question C was that Q is the equilibrium quantity, and we found that out being equals 7,880. So what we want to find out is that at this quantity reaching equilibrium, then what should be the corresponding price? And so at this point right here, we have two options to find the equilibrium price right here. You can go with technically you have two equations. One of them is the 67,374 minus 4.77 Q. Substitute your equilibrium quantity into that equation. So you can go with 67,374 minus 4.77 times 7880. That's one option. The other option would be you can substitute this same equilibrium quantity into your other supplied into your other equation, being the supplied equation right here, where it says P equals 3.78 Q right here. And so I'm leaving that for you to make your smart decisions of which equation is better to use. It will give you faster results, even though it's the same result right here. Substituting in 3880. And so either way, it's going to give you the value. Calculation comes out saying that it's 29,786.4, and this is in dollars amount. And so once again, imagine that if you were using the other equation, it would give you the exact same answer. I made my choice going with this equation simply because it's shorter.